Bismillahirrahmanirrahim. Assalamu alaikum. We are doing linear equations, chapter number 5, D1. Up till now, we have discussed equations, and in the equations, left hand side was equal to the right hand side. Both the sides were equal, and we were solving equations and the word problems. But the things are not always like that. It could be that the left hand side is not equal to the right hand side. When we say that the left hand side is not equal to the right hand side, is that it's a case of inequality. And in the case of inequality, what are the possibilities? We have 4 possibilities. The first one is greater than. So the left hand side is greater than the right hand side. Second possibility is lesser than. Left hand side could be lesser than right hand side. Fourth possibility is greater than equal. And the fourth possibility is lesser than equal. So we have these 4 possibilities which might occur in any of the inequality. So let's take an example from the book. The example I'm going to take is from the practice now 9, and let's solve it and see what we actually mean by this inequality. Practice now 9. Page 128, and the problem is 15x is greater than 75. What we have to do? Solve and show on the number line. Okay, so this is the case of an inequality. We don't have equality over here. It's greater than sign. It means that when we get the value of the variable, it's going to be greater than some value. Let's find out. And on the left hand side we have 15x, on the right hand side 75. We're going to solve it in the similar way we were solving linear equations. So what we are going to do? We are going to divide by 15 left hand side and by 15 right hand side. So on the left hand side we will have x after dividing by 15. 15 divided by 15 is 1. And on the right hand side we have 75 divided by 15. So 5 3s are 5 1 and 5 15. And 3 1s are 3 5s are. So x is greater than 5. So whatever the case is, the value of x cannot be equal to 5 even. It is greater than 5. That means 6, 7, 8. It could be any value, but something has to be greater than 5. And how we are going to show it on the number line? For the number line, let's say this is our number line. 1, 2, 3, 4, 5, 6, 7. And on the number line, we are going to show it like this. It is greater than 5. Okay? So, I'm going to draw a circle on 5, and with the circle, I am marking an arrow. The circle is not filled. Okay? The circle is not filled because the value is greater than 5. The 5 is not included. The value has to be greater than 5. That is why the empty circle mean that the 5 is not included. It is beyond 5. And the arrow is going beyond 5. It could be any number, but has to be greater than 5. So this is the way we show it on the number line. Okay, now let's take another example, and it's also going to be the part 2 of the question 2 of the practice now 9. Then the question is 6x is greater than 7. In this case, what we have to do? We have to find the smallest integer value of x. The scenario we have here is 6x is greater than 7. Again, it's an inequality. The relation is of greater than. And after we solve this and find the value of x, what we have to, the result should be that we have to give the smallest integer value of x. Answer has to be an integer value, not in decimal numbers, not a real number. The answer has to be an integer value. Remember this. So let's solve it. So x divided by 6, we get x here. And on the right hand side, it's 7 divided by 6. Okay? Another way, we can also say it like this: 1 whole 1 by 6. So it is something, it is very clear that x is greater than 1 whole 1 by 6. But we have to find the smallest integer value. So if the value has to be greater than 1 whole 1 by 6, so what comes after 1? What is the integer value which comes after 1? That is 2. After 1 is an integer, and after 1, the second integer is 2. So the possible smallest integer value for x is 2. Okay, it is 2 because we have to give answer in an integer value. So 2 is an integer. We cannot say it like it's greater than 1 whole 1 by 6. We have to give an integer value. That is why we say it's 2. Okay, so now let's take another problem from exercise 5D. So exercise 5D, question number is 2A, and the problem is 3x lesser than equal to 18, and we have to solve and show on number line. Okay. So this is a case where x is lesser than equal to 18. We're going to solve it as before. So we have to divide left hand side with 3 and right hand side with 3. So by dividing by 3, we have here is x, which is less than equal to 18 divided by 3, and we have here less than equal to 6. Okay, so the value of x can be 6 because equality is here. It is lesser than and equal. It can be 6 or 5 or 4 or 3 or any value which is equal to or lesser than 6, but cannot be greater than 6. Now we have to show it on the number line. For the number line, we are going to show it like this, since it is equal to 6 or lesser than 6. So a circle is drawn on 6 and this circle is filled. It's a filled circle, not an empty circle. It is filled because it is lesser than equal. 6 is included not exclusive, okay? 6 is included. And we are going to show it with an arrow like this. It means that the value is less than or equal to 6. This filled circle means that it's 6 is included, and the value can be any value which is less than or equal to 6. So we have solved it and shown on the number line. Let's take another example from the same exercise. And it is question 2, C part. It is 3y less than minus 36. Okay, solving in the same manner, we are going to divide by 3. Okay, as long as we are dividing by any number which is a positive number, there is nothing happening to the inequality. If it is less than, it will remain less than. If it is greater, it will remain greater, because we are dividing with a positive number. Okay, like I'm going to divide here with 3. 3 is a positive number. Whenever you are going to divide with a negative number, then the inequality changes. And we will discuss that with some problem when we have any such problem in which the negative number has to be applied. So up till now, what we are doing is we are dividing with positive numbers, okay? So y less than minus 36 divided by 3, and it is y less than minus 12. And now in this case, the answer says that it is y is less than minus 12. It means that minus 12 is not included, but the values are less than minus 12. So what are the possible values? Minus 13, minus 14, minus 15, minus 16, because it is lesser than minus 12, okay? And 12 or greater than 12 values are not included. So let's show it on the number line. So just for the sake of easiness, I'm just writing here minus 15, minus 14, minus 13, minus 12, minus 11, minus 10. Okay, and in our case, it is y less than minus 12. It is less than. So minus 12 not included. So drawing a circle on minus 12, and the circle is not filled. Okay, and the values are less than. So an arrow in this direction. The direction of the arrow is showing that the values are less than 12, but this empty circle is showing that the minus 12 is not included. So इससे बात समझ आ रही है कि जब भी कभी आपका सर्कल फिल्ड नहीं है, इसका मतलब ये कि जिस नंबर के ऊपर सर्कल फिल्ड नहीं है वो नंबर इंक्लूड नहीं है, और अगर सर्कल फिल्ड हो गया तो नंबर इंक्लूड है, और अगर नंबर इंक्लूड हो रहा है तो यहाँ पे भी साथ इक्वालिटी साइन आएगा. ओके, अच्छा जी, ये तो सिंपल प्रॉब्लम्स थी. Now let's take couple of word problems of inequalities.
Go.
Okay ji, the problem I have taken is from the review exercise question number 19, and the problem is admission to a school play cost $12.50. Form an inequality and solve it to find the maximum number of tickets Junwei can buy with $2.50. Okay, so Junwei, in this, whenever we are doing a word problem, first thing is, so we have to underline those key areas which we are going to use to form a linear equation or an inequality. Okay, in both cases we need some key areas. So the key area, we have a Junwei. She has amount of $250. Cost of each ticket is $12.50. So what we have to do, we have to form an inequality. Okay, and the last thing, we have to find the maximum number. Okay, this is very important. This I am going to circle it. This is very important. Maximum number. Now let's visualize it. Junvi has $250, and with these $250, she wants to buy tickets to a school play, and cost of each ticket is $12.50. अच्छा जी, अब अगर कितनी tickets वो खरीद सकती है? It's just like that. You're going to a market to buy chocolates, okay? And you have, let's say, $100 in your pocket. Now from those $100, you can buy a certain amount of chocolates. You cannot buy more than $100 chocolate, right? No shopkeeper is going to say, okay, you have $100, but if you want to buy for $150, I don't mind. No. Every shopkeeper will say, you have $100, you can buy any number of chocolates which are within $100 or for $100, okay? So, she is spending $250. So, इन्हीं $250 को use करते हुए either she is going to spend whole of the $250 or she is going to save some, but she has to buy the maximum number of tickets, okay? Maximum number of tickets इस amount में. अब कितनी tickets purchase की जा सकती हैं? What could be the number of the tickets? We don't know. So let's take variable x to represent number of tickets. Let x represents number of tickets. Now let's form an inequality. So number of tickets is x. What is the cost of each ticket? It is $12.50, and amount we have is $250, and we have to purchase maximum number. Whenever there is a case of maximum, you have to put the sign of less than equal, because you cannot go beyond this amount, okay? Either you are going to spend all of the $250 or you will save some money, but you cannot go beyond this. So the number of the tickets, when we are forming an inequality, the relationship will be of less than or equal to, okay? So the inequality, let's write it again. 12.50x less than equal to 250, okay? So this is our inequality. Either she is going to spend whole of the money, which is represented by the equal, or she might be spending little less than 250, so she cannot go beyond. So whenever the case of maximum, the relationship will come for less than equal, okay? So now x is less than equal to 250 over 12.50, okay? And after dividing, what we are going to have here? Less than equal to 20. So the result is Junvi can buy maximum of $20 tickets. Okay, so this is the maximum number of tickets she can buy. If she wants, she can buy 10, she can buy 5, she can buy 18, but maximum is 20. So this maximum means this is the limit. She cannot go for the 21st ticket. Okay. Okay, I hope it is clear. Now let's move to another example, another question from the same exercise. Okay, now we have a problem. Question number 22. The problem is a ship can carry a maximum of 60 passengers. By setting up an inequality, find the minimum number of ships that are needed to carry 400 passengers. Now, to form an inequality, we have to first find the key areas which will help us to form an inequality. The key areas are: a single ship can carry up to maximum up to 60 passengers. Okay, and then how many passengers have to be carried? 400. And what is the condition for this inequality? Minimum number of ships. Okay, and this minimum, again I am circling it, this minimum is very, it's a very necessary thing. Okay, so a single ship can carry up to 60 passengers. There are about 400 passengers to be carried, and we have to form an inequality with minimum, which can solve the minimum number of ships required to carry the passengers. Okay, so how many ships we need to transport these 400 passengers? We don't know that. So let's take a variable. So let x be a variable to represent number of ships. Okay, so we know that a single ship can carry up to 60 passengers. So 60 into x, 60x, one ship, 60 passengers, 60x. So how many passengers have to be transported? 400. What is the relationship of us between this 60x and 400? How many ships are needed to transport these 400 passengers? Now it depends on this minimum. Yeah, that means that kam se kam kya hoga, yani ke what is the minimum number of ships, because less than that we won't be able to transport 400 passengers. Okay, so we have to deal with minimum case. So for that matter, now the relationship will be of greater than equal. Okay, it's not, for the maximum it was less than equal, and for the minimum it is greater than equal. Okay, now let's solve it. X divided by 60, we have x greater than equal to 400 divided by 60. So we can cancel out 0 with 0, and we have left here 40 divided by 66. So which is x greater than equal to 6 whole 4 by 6. Okay, so it's a fraction, 6 point something, but we can never have some number of ships in points. We need number of ships in a whole number. So the minimum number of the ship required, so the minimum number of ships required is 7. So because we cannot say that 6 point something ships are needed, it is 7. The minimum number of the ship is 7, but it is minimum. So what this relationship says, x greater than equal to 7. That means that you may have 7 ships, or you may have any number of ships greater than 7. Okay, the minimum number is 7. That means 7, from 7 to any number of ships. But less than 7, you cannot be able to transport this much number of the passengers. Okay, hope this explains you the inequality issue. With this I conclude chapter number 5. Hope you have understood the concepts in the chapter number 5. I'll be waiting for your feedback. Do give me feedback that was I going fast, slow, or am I giving explanation properly or not. I'll be waiting for your feedback. So thank you very much.